Hello, this is the report of my current situation in chemistry. First of all, we need to be aware about the importance of the chemistry in our society and in every day to day, because thanks to chemistry, we can have a lot of essential elements. For example, the medicine or the soap, something that is very essential and very obvious along our day. But other important point is we need to connect the society with the science, in this case, in specifically with the chemistry, uh, and more if we talk about the young people, because the science and chemistry can resolve a lot of our problems and can take out a lot of doubts, and with that, we can have a better society. So, one example of how chemistry can improve our lives is the airbags. The airbags in general works with sensors that detect a change in acceleration, and when a crash occurs, these sensors activate a mechanism that take out some gases, and these gases make a reaction, and for that reason, the airbags appears very fast in milliseconds, and that's how it works in general. And now, the gases that the mechanism take out make three reactions, and the first one is like the main reaction. And when we have the products, the reaction products sodium and nitrogen gas. For example, the second reaction we have sodium, another substance, but the main reaction is the first one. It, and the reactants is acid of sodium, and that are the products. Oh, now, how can we know how much substance we need to know to make airbag works in a correct way? Well, we need to know that in general, an airbag have a capacity of 65 liters, and with that information and taking the pressure at 1.1 atm and 80 degrees Celsius, we can take this information and put it in the formula of ideal gases. And how can we see in the section number 2? We just need to substitute the data, and with that we can get the number of moles of the nitrogen gas that we need, because this is about the main reactions, the first one, and we are talking about the nitrogen gas. And the final result is that we need 106.6 grams to make that complete reaction in an airbag. And now, to know the amount of energy that is given or taken by the reactions, we need to know the enthalpy, and the enthalpy is a thermodynamic data that just gives us that data, the amount of energy that a system or a reaction give or take. And for this, we need to know we need to know the enthalpy data of each element of substance involucrated in the reactions. And first one in the left side, we have the enthalpy of the products, and we can see that it's zero, because these products in this way is the more stable form, and enthalpy in stable form always is zero. But if we see the enthalpy of the reactants, we can see that is 21.9. And if we follow the equation for the difference of enthalpy, we are going to get that the energy is minus 42.2 kilojoules. And that means that the reaction is exothermic. So the reaction lose energy and give it to the environment. And now we need to talk about the toxicity and reactivity of the reaction, again of the main reaction. And about the toxicity, the acinonoside is more toxicity component in all the reactions because it's very toxic for human life and for life in general. And for that reason, there is in a very small quantities. And for example, the sodium is toxic, but only in high quantities because actually we need a little bit to survive and stay alive. And about the nitrogen gas, it's not toxic. The only thing is that it's well, we can see it and it can replace the oxygen, and we can have problems with that. And about the reactivity, the sodium and the sodium side are the more reactivity of the three components of the main reactions. And the sodium side is very reactivity and can react with uh, fast or strong impacts. And now, if we can see uh, how useful is the chemistry in the airbags, we can know that here that the airbags in a period of 30 years have saved an approximate of 50,000 of lives. So yeah, and if we take account that the car crash is very, very common in all the world, we can say that the airbags is a useful invent and help us along our lives. And now we need to know that how the reaction is made of a toxic component. It has toxic residuals that the toxic residuals have a specific way to be treated. And we can say that we can see here that the first step is called the residuals like hazardous material. And with that, we can have a special treat with the residuals. And well, we need to take take it with care and put in a special place, and in general have a special treat with them because the residuals are toxic and can be very dangerous for the environment and for us like humans in the accident. And here are the reference, and that's the report of the problem situation.